today we're going to start our conversation of sine graphs. So we finished up with cosine last week. So this week we get to go on to cosine and find out some good little qualities on that one. So today we're going to do a little bit of kind of graphing these, figuring out like what this all means when it comes to our unit circle, and you guys have a copy of that unit circle. So we got a couple problems to kind of work through, talk through about what's going on, and then we got that unit circle. So I'll kind of show you some of, if you're going to keep that unit circle, we're going to keep adding to it little piece by little piece as we kind of go through this rest of this chapter. So don't think it's a one and done kind of situation, right? So hold on to that baby. So we got that circle to go over, talk about those points, and then onto the unit circle. And then tomorrow we'll do a little bit more with cosine. Sound like a plan? All right, sweetos. All right, so I know we've kind of had a little bit of this discussion. If I have a unit circle, when it comes to a unit circle, we always know something very special about the radius.
1.
Yep, it always equals 1, right? And definition of the radius is from the center of the circle to any point on the circle, right? So all of these little guys would all have a value of 1, right? And if it comes to making the circle is a whole bunch of points that go all the way around, and they're really close together, and as they get closer and closer together, the more little points you plot, it actually makes that circle. Kind of no different than a line. A line is made up of a whole bunch of points, right, with the same slope. So when it comes to this circle, we want to be able to figure out that point, and that point is always going to be a x, y coordinate, right? So we want to be able to figure out what that x and that y coordinate is. So we have to go over some distance, and we got to go up some distance in order to get to that point. And the only thing we know is that radius is 1. So that's what good little stuff we get to work with. Sound good? Mm-hmm. So if I kind of draw this a little bit, right? To get to that point, we had to go over so far on the x-axis. Maybe this isn't the best color. I want to go. We'll just make some good sound effects, right? So I went over some distance of x, and then after I went over some distance of x, I went up a distance of y, right? And I made a cute little right triangle. And we know a lot of good stuff about right triangles, don't we? Right? So if I were to draw that little right triangle over here onto the side, right? Oh my. Having fun up there, right? We knew this was a right angle. This was our x. This was our y. We know this little guy over here was 1. And we know that this angle is 34 degrees, right? So a couple things we know about triangles, right triangles. We know the Pythagorean theorem. A squared plus b squared equals c squared. Would Pythagorean theorem help us out right now?
No.
No, because we got 2 unknowns.
You know
What would?
adding 90 and 34 and subtracting it from 1 and
Right, so you could figure out that other angle if you wanted to.
Oh, we don't need the angle, don't do we?
Right, but yes, exactly, not really, right?
Oh, just kidding.
No, you're good. Yeah. So we did start learning about these little things on trig, right? And in geometry, you learned it too. That SOHCAHTOA. Remember SOHCAHTOA?
Mm-hmm.
Different people kind of really some people write it this way. Some people write it as the sine is opposite over hypotenuse. The cosine is adjacent over hypotenuse. And then the tangent is opposite over adjacent, right? So different people write it different ways for that SOHCAHTOA. So that SOHCAHTOA helps us because ultimately, ooh, I lost my pointer. We're looking at angles and we're looking at sides, right? So when it comes to what we have an angle and we have a side. So that's when that sine, cosine, or tangent is really going to come in handy. just can never pick the right color. I don't know. So let's name our sides. So when it comes to figuring out that opposite, adjacent, and hypotenuse, it always comes from like the angle that we're working with. So we're working with this 34 degrees. So opposite, adjacent, or hypotenuse. What's my y gonna be? Opposite, because it's on the opposite side of the triangle, right? So this is our opposite, right? 34, our x is gonna be adjacent, yeah. Because you always want to sit next to that cute kid by the name of adjacent. And so he's next to that angle. There's no Jasons in here, right? It's like, I always got to think about that. Like, ooh. And our 1 is going to be the hypotenuse because that's across from that 90-degree angle, right? And then so we know that this one's the hypotenuse. So which one do we want to do first? Do you want to do x's or y's? You want to do y? Sure, we can do y first. So if I want to do y, so from this angle, if I want to do y, what's the other side that I know? 1, which is the hypotenuse, right? So if I want to do y, I have opposite and hypotenuse. So which one of these guys has to do with opposite and hypotenuse? The sine, right? So the sine of what angle? 34 equals opposite y over hypotenuse 1. Right? If it makes you warm and fuzzy, you can make them both into fractions. So that way we can cross multiply. Right? These are equal, so numerator times denominator equals numerator times denominator. Right? So when I cross multiply, I'm going to get y equals, I'm just going to write the 1 just for poops and giggles. 1 times the sine of 34. Right? So we're going to want to know what that value is. So we're going to put it into our handy dandy calculator. And our calculators are going to be in that degree mode. Right? So the sine of 34 gives us, let's go 0.56. Right? So we know when it comes to this point, we just found the y value, which was 0.56. So what's the other value we got to find? X. So if I'm looking at x, I got something to do with adjacent. And granted, you could do adjacent over opposite because you just found out that y was that 0.56. But honestly, I just go back to what they give us. That way, if you made a boo-boo on that y value, if you made a boo-boo and you use it, now you got 2 boo-boos. Right? Hey, boo-boo. So if you use the 1 that was given to you in the problem, hopefully you can maybe possibly get it right this time, right? So if I'm looking from this angle, my x is my adjacent and my hypotenuse is 1. So I got adjacent and hypotenuse. So, yep, so I'm going to look at cosine. So the cosine of 34 is going to equal, yep, x over 1. Yep, and if you want to make that a fraction, try some cross multiplication. Cross multiply, what do we get? X equals the cosine of 34. You guys put that into your handy dandy little calculator, didn't you? 0.83, right? So then now we know that the x value is 0.83. Right? So how far did I go over? Yep, 0.83. How high did I go? 0.56. Yep. And then you can even check, are both of these positive? Yeah. And if I'm in the first quadrant, should they both be positive? Yeah, so you can always check on that one, right? Yeah, not yet, but we're going to.
Okay.
Yep. So then when it comes to these, that x value, we looked at cosine, and our y value, we looked at sine, right? So if they give us the angle, you think we're good at finding all of the points? Yeah, we are, Mrs. Fitch. That's great. What would happen if they sat there and instead of giving us the angle, they gave us side measurements and they asked us to find the angle? Yeah, so let's say they tell us that the cosine, ooh, that's kind of funky looking. What is going on? Let's say the cosine equals 3/4, and they want us to find theta, which is that angle.
Couldn't you do like inverse sine?
Yep. Yeah. So they're telling us that cosine theta equals 3/4. Okay? And we want to find this little theta guy. We want to find the angle that they're taking the cosine of. So we have to get rid of this cosine, but those guys are not multiplied. But in order to get rid of the cosine, we multiply both sides by the inverse. So a number times its inverse goes away. So those guys cancel out. And then we end up with theta equals cosine inverse of 3/4. So this is our second cosine button on our calculators. So second cosine, 3 divided by 4. And that tells us that theta, our angle, is like 41.4 degrees. All right. You ready for this good guy? All right. So I'm going to help you out with some of these angles going around, right? I'm going to start off. So usually the way I kind of do these, so the dotted lines, and you can do this either way. So the dotted lines, I'm going to fill those in as degrees. And if you remember later in this week, we're going to figure out radians. And that's what I'm going to put in that next line. And then this is that coordinate point, that sine and cosine, or that x and that y. So today, we should be able to fill out all of our, I'm doing these as degrees, and then we're going to fill out these points. All right? So, to start with, right, if I start at the center of my circle, and I just went this way, and that was my initial side and my terminal side, that would be 0 degrees. So on that very first one, I'm going to fill that one in as 0. And if you want, you can put the little degree symbol on there. And my little lines aren't showing up very well. If I squeeze in, well, can we get it? Maybe. Well, we'll just keep it big for right now. I'll shrink it as I need to, right? If we go, if this was my initial side and this was my terminal side, what degrees is that going to be? 90. So I'm going to fill this guy in as 90 degrees. If I went all the way across, how many degrees would that be? 180. What would my guy at the bottom be? 270 degrees. Yep, good job. And then if I come back all the way around, so if I technically went all the way around this way, it'd be 360. And that's what that line under that 0 degrees is for. And those two should be the same exact measurement. It's just giving you to where if you were at 0 or if you were at 360. So it'll match up, right? Our little famous, because think of those 30, 60, 90 degree triangles and those 45, 45s. So those are ultimately what we're filling in. So this first degree is going to be 30 degrees. My second one is going to be 45 degrees. And then the next one's going to be,
60.
yep, 60 degrees. And then we're gonna kind of like keep going around, or you guys are gonna keep going around. So what I do on these, this is always like right dead in the middle, right? So this is always gonna be another 45 degrees. So I always start with that middle one. So I know this here is 90. So from here to here would be 90 plus 45. Make sense? So what's 90 plus 45?
135.
Yep, 135. So the one in the middle is 135 degrees. How do I go from, I didn't want that guy. How do I go from 45 to 60?
15.
Add 15, right? So from 135, I would add 15, which would give me 150, right? And then how did I go from like 45 to 30? What would I do?
Minus 15.
Minus 15. So to go back, I gotta subtract 15, and what am I gonna get? 120. Yep. So you guys can fill out the bottom ones. Does that work? And then I'm going to try and get you guys today to also fill in these XY coordinates for just this first quadrant, right? So to fill out my 0 degrees, I'm on a unit circle, so my radius is always 1, right? So from here to here, I got to figure out my XY coordinate.
0.
So did I move it all on my X to get to this point?
Yeah.
How far did I move on X? 1. Did I move up or down any?
No.
Nope, so my Y would be 0. Then I'm going to jump up to 90 degrees on you guys. So if I start on the origin, then I got to go up to this point. So did I move anything on my X? Nope, so my X is going to be 0. Did I move anything on my Y? How far did I move on Y? 1. So that would be the point 0, 1. Let me do one more for you. So for 180, if I go from here to here, did I move on my X?
Yeah, over negative 1.
Yep, I went over -1. Did I move on any on my Y? Nope. So that would be -1, 0. Oh no, I'm out of quadrant 1. All right, you guys ready about how to figure out the X's and the Y's? So just like on that 34-degree angle, right? So to figure out my 30 degrees, hang on. I'm going to drop that guy down, right? And I'm going to make a right triangle, right? And what's my radius on a unit circle? 1, right? So I'm going to on a scratch sheet of paper, right? That's kind of the triangle I made, right? This was 30 degrees. We made it into a right triangle. And we knew that the hypotenuse, or our radius, was 1, right? The bottom's going to be our X, and this is our Y. So if we think of our SOHCAHTOA, right? Which one do we want to do first, X or Y? Y. You always go to Y, don't you? That's fine. So if I want to solve for Y, so from 30 degrees, Y is my opposite, tangent, or hypotenuse? Opposite. And I know the 1, which is my across from the right angle. That's always going to be my
Hypotenuse.
Hypotenuse, right? So I'm using opposite and hypotenuse. So anytime I'm looking for y, I know that I'm always going to use my sine. Right, this is always going to give me my y value. So the sine of 30 equals y over 1. Right? So the sine of 30 equals y. So we can put that into our calculator.
Okay.
And then what are we going to do to find x?
Cosine of x,
Yeah,
cosine
cosine of
30 equals x.
over 1, right? Cross multiply. So we're going to get the cosine of 30 equals x. Yes. Yep. And then you're going to do it again for that second angle, which is 45 degrees, right? So then you're going to make another triangle. Whoops, really poorly drawn. This guy's going to be 45, right? And then you can figure out, and actually on that 45, what do you know about this angle up at the top? That's also going to be 45, right? If you wanted to, you could fill it in there. This is your x, this is your y.
So pretty much every time it's just gonna be like sine 45, cosine 45.
Yeah.
Every type of two calculator.
Yep. So I want you guys to be able to fill out all of these points in this first quadrant. And then tomorrow we'll talk about how to get all of the rest of them. So you don't have to make